Long-range wireless control of an RC plane is always a challenge. In this episode, you will learn how to make your own 5 to 15 kilometer long-range RC plane transmitter and receiver controller using the Rylr896 Lora Transceiver modules by the Reyax Technologies. The same long-range wireless control system can also be used with RC cars and other electronic projects. The PCB boards used in this project are sponsored by the PCBWay company. PCBWay is quite professional in the field of PCB manufacturing. You can try their services at extremely low prices, only $5 for 10 PCBs and $30 in total for 20 PCBs assembly. Besides this, the new members also get a $5 bonus. The Gerber files of the PCB boards used in this project can be downloaded from the PCBWay official website. You can find a link in the description. We will be creating multiple channels for controlling the 1000 kV brushless DC motor. I'll be using a potentiometer for controlling the speed of brushless motor. You can replace the potentiometer with a 2-axis analog joystick. Anyhow, using the potentiometer, I can control the speed of brushless DC motor to its full capacity. We will also create two channels for controlling a pair of micro servo motors. These servo motors will be used for the up and down and left and right movements of the RC plane. I'm using delays in the program. If you want a quick response, you can remove the delays. The program still have some bugs which I'm sure while working on this project you will definitely fix them. Right now I am controlling only 3 angles, 0, 90 and 180 degrees. If you want a smooth movement, you can use different angles. Anyhow, you can increase the number of channels. More buttons can be added to control lights or something else. Before I'm going to explain the circuit diagrams and programs, first let's go through the components used in the making of transmitter and receiver circuits. This is the transmitter side based on the Arduino Nano. You can solder everything on a single PCB to reduce the size. I will explain all the connections in a minute. Next to it is the 2-axis analog joystick which is used to control the servo motors to control the up, down and left, right movement of the RC plane. This is the Rylr896 Lora Transceiver module and is used to send the control data to the receiver side. You can set different modes using the AD commands which I have already explained in my previous tutorial. I will provide a link in the description. Finally, a potentiometer which is used to control speed of brushless DC motor. The transmitter side of the RC plane is very simple, built around a few electronic components. Now let's have a look on the receiver side of the RC plane. The receiver side consists of the 1000 kV brushless DC motor. Next to it is the 30 ampere speed controller. This is 11.1 volt 2200 mAh LiPo battery pack used to power up the brushless DC motor and the speed controller. This is a 5 volt regulated power supply based on the LM7805 voltage regulator used to power up the micro servo motor, while the other servo motor is powered up using the Arduino. This is the Rylr896 Lora Transceiver module which is used to receive the data sent by the transmitter. You can solder all the electronics on a single PCB by following my connections which I will explain in the circuit diagram. Without any further delay, let's get started. The components and tools used in this project can be purchased from Amazon. The components purchase links are given in the description. As you know, Arduino is based on the 5-volt controller, while the Lora transceiver module by the Reyax Technology can handle voltages from 2.8 to maximum 3.6 volts. The typical voltage is 3.3 volts as explained in my previous getting started tutorials on the Rylr896 Lora Transceiver modules. From this information we know that this module cannot be directly interfaced with the Arduino. For this we need some kind of converter which can convert 5 volts into 3.3 volts. But instead of using the converter we can use a simple voltage divider circuit. As you can see, 4.7K and 10K resistors are connected in series, which gives me 3.4 volts, which is perfect for the Reyax Lora Transceiver module. A wire from the middle of these resistors is connected with the RxD pin of the module. The other leg of the 10K resistor is connected with the ground, while the other leg of the 4.7K resistor is connected with the TX of the Arduino. The Rx pin of the Arduino is connected with the TXT pin of the Lora module. The ground of the Lora module is connected with the ground of the Arduino. The 2-axis analog joystick power supply pins are connected with the Arduino's 5 volts and ground. The VRX and VRY pins of the joystick are connected with the Arduino's analog pins A2 and A3. Potentiometer or variable resistor is connected with the analog pin A1 of the Arduino. So that's all about the transmitter side. Now let's have a look at the receiver side circuit diagram. The Rylr896 Lora module connections remains the same. This 5V regulated power supply based on the LM7805 linear voltage regulator is used to power up the micro servo motor. The other servo motor is powered up using the Arduino. The signal wires of both the servo motors are connected with the PWM pins 5 and 9 of the Arduino. 3 wires of the 1000 kV brushless motor are connected with the 30 ampere speed controller. The yellow wire should be connected with the middle wire of the speed controller, while the red and black wires are connected with the other 2 wires of the speed controller. If the brushless motor rotates in the wrong direction, you can simply interchange these 2 wires. On the other side of the speed controller, we have a total of 5 wires. The red and black wires are the power supply wires, and these should be connected with the LiPo battery pack red and black wires. The white wire should be connected with the Arduino's PWM pin. In my case, I'm using pin 3 of the Arduino, while the black wire should be connected with the Arduino's ground. So that's all about the receiver circuit diagram. After some soldering, my 5V regulated power supply was ready, which now I can use for powering up the servo motor. These are the 2 PCB boards designed for the Rylr896 Lora modules. These PCBs are manufactured by the PCBWay company. As you can see, the quality is really great. You can use this area for soldering some sensors, but if you don't need this area, you can simply cut this. This will reduce the size and weight. The Rylr896 Lora module nicely sits in, and then using these female headers, it can be easily interfaced with any Arduino or ESP boards. Finally, I connected everything as per the circuit diagram already explained. Now let's have a look at the transmitter and receiver programming. In this project, two programs are used. One program is written for the transmitter side and the other program is written for the receiver side. On the receiver side, as you can see, this servo library is used, which you can download from our website electronicclinic.com. I will provide a link in the description. These programs are almost the same as explained in my previous tutorial based on the multiple sensor monitoring. This time I did some minor changes which I have explained in the article. These programs can be downloaded from our website. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.